You mentioned earlier on in our conversation the constructive nature of AI, and you've heard, I'm sure, the loud detractors, the concern about the destructive nature. What, if any, concerns do you have about AI being misused or becoming destructive? And what are the guardrails we can put around that?
I think with any technology, you will have that conversation. Right? Any technology could be, technology itself is not good or bad, it is the people using it. Right? Now, there are some issues with the current way AI is built. Most of the issues, it's not the model itself, although in some cases it is. It usually comes down to data. So data privacy is an issue. The kinds of things you can use are an issue. For example, if you have a model that is just, you scrape all the data off the internet, the things that are abundant on the internet is negativity. A lot of conspiracy theories, a lot of false information, people telling certain narratives. And now, if you have a very large overparameterized model, it isn't distilling that or condensing it, it is memorizing all of it and storing that as raw facts. Now, all you need is somebody who can come up with a kind of prompt and access certain information. Now, the model is giving certain outputs that it shouldn't, right? And there are issues like that. I am hopeful. I think, so I mentioned earlier that I don't believe we're done exploring models yet. I think the path forward is likely going to be that we may be seeing the limit of transformer models because we're starting to run out of data. And I personally have a feeling that there's going to be an emergence of a new architecture soon, in the next, anywhere between from the next 6 months to the next 2 years, or maybe longer. And this architecture is going to have a few criteria. It's going to allow for continued scaling of model size, because we do know that greater model size results in new emergent properties. If you look at the brain, for example, there's a roughly 4 order of magnitude difference to the parameterization of that, versus the amount of data samples you pick up over your lifetime. I think larger model is going to create more stability and steerability, so you can have better control over outputs and eliminate hallucinations and take more complex goals at higher levels. And it's going to create essentially a goal-oriented architecture instead of a prompt-based one. We may have a world model which works as a source of ground truth. And from that, you can think about having a generative capability. You're making predictions about potential futures, and then you're applying some form of a cost function to that to improve reasoning abilities. I think multimodality is going to play a more important role. In that way, you can have more context about the environment. Think like a joint embedding space where words and images have strong and weak ties, and relationships can be traversed and played with, and so on. And I don't believe it's going to execute a predetermined number of steps to get to an output. I think you could defer more compute to runtime, where you can scale up the model and have larger state space. This is something AlphaGo Zero did as well. So it's a pretty powerful concept, because traversing through a predetermined number of steps or layers to get to an output is somewhat limiting. You don't know the amount of computation you actually need to solve the problem, or how much reasoning you need. So I think that's going to be somewhat goal determined. And how the granularity to which it breaks down. I think models are going to have to get more sample efficient. That way, the DNN generalizes with fewer data points while still being very overparameterized. And this could come possibly from the discovery of a better prior. I think my architecture should be somewhat modular, so that parts of the model could be retrained without having to redo the entire model from scratch, which could become expensive. And that way you can overcome data concept drift types of things as the model interacts with the world, and maybe align them better to users and their individual needs and personalities. And then, adapt to new contexts as users are giving them. And least by my estimates, if I actually try to construct that, I think it's going to require somewhere between 3 to 4 orders of magnitude more compute than what we've seen today. And today we're already at zettascale, which is kind of ridiculous. But I think that's how we solve the problem.